Hello and welcome to this GCSE Chemistry mini-masterclass. In this session I'll be focusing on all of the key concepts related to electrolysis. This is relevant no matter what exam board you are studying for, and the vast majority of the content is applicable to both foundation and higher tier students, with an extra little bit of higher tier only content on half equations. As always, I will be helping you to secure knowledge of the facts and how to apply these effectively to exam questions. Let's get cracking. Right, what is electrolysis then? It's the decomposition or breaking down of a compound containing ions using electricity. Okay, so that's the type of energy that we're using to perform electrolysis. The compound being broken down is called the electrolyte. Just a quick reminder, for there to be an electrical current, you have to have a flow of charge, okay? And in this case, it's the ions that will be carrying that charge as part of the electrical current. Now, the electrolyte, i.e. the substance that we are breaking down, must be in liquid, i.e. molten or aqueous form. In other words, dissolved in a solvent to form a solution. As I mentioned previously, there must be a flow of charge. So this will not work if the substance you are using is a solid, because for ionic substances, we know they have a lattice structure with ions vibrating about fixed positions. So there's no flow of charge. For something like an aqueous solution, the ions are now free to move, so there is a flow of charge. We'll have a little look at the electrolytic cell in a moment and see what actually happens to the ions and how they carry that charge to complete the circuit in a moment. Remembering the key terms, there's quite a few of these in this topic, and it's understandable that a lot of students find this quite tricky. A few little ways of remembering some of these key terms. Panic, positive anode, negative is cathode. So when we look at the electrolytic cell, we can see we use two conducting rods, often made of the likes of graphite, and based on their connections to the power supply, might be a battery, might be a power pack, we have a positively charged electrode called the anode and a negatively charged electrode called the cathode. And that's a little way of remembering their names. The cations within the electrolyte are positively charged, and some students like to remember this by cats positive, sounds a bit like positive, or positive because cats have paws. And if the cations are positively charged, then the anions must be negatively charged. And due to opposites being attracted to one another, the negatively charged anions will be attracted to the positively charged anode, and the positively charged cations will be attracted to the negatively charged cathode. And I'll show you this in action with a specific example in a moment. When the ions arrive at their respective electrodes, there are two reactions that occur. One is oxidation and one is reduction, where the ions are discharged to form atoms. Okay, now at the anode, oxidation, A for anode, we get the loss of electrons occurring, i.e. the ion will lose electrons when it discharges to form atoms. And in reduction, the C there linked to the cathode, we get the gain of electrons by the ions when they discharge to form atoms. And oil rig is a little way of remembering what oxidation and reduction means. You could be asked to describe gas tests within this topic as well. So a quick reminder of three common ones if we were testing for the products in a particular electrolysis experiment. We've got the test for hydrogen, where we do not say the squeaky pop test, okay? That will score 0 marks in an exam. We say we put a flame in the gas, or ignite the gas, or put a lit splint in the gas. And if hydrogen is present, we hear a pop. For the test for oxygen, it's a glowing splint that we place in the gas, and if oxygen is present, the splint will reignite. And for the test for chlorine gas, it's damp blue litmus paper that we place in the gas, and if chlorine is present, the litmus paper turns red, then white, or it's bleached white. Okay, let's have a look at a scenario then. This is the electrolysis of molten sodium chloride, NaCl. And if it's molten, then I know the ions are free to move, and I've only got Na plus cations and Cl minus anions. I know those are the only two types of ion I've got present because it's molten sodium chloride. It's not a solution. What's going on then? Well, to begin with, let's label the electrodes. We've got the positively charged anode and our negatively charged cathode. And in the electrolyte, I have my sodium cations with their positive charge and my chloride anions with their negative charge. The negatively charged chloride anions will migrate, which means move, to the anode. Why? Because they're attracted to the anode. When they arrive, they will discharge, and those chloride ions are oxidized to form chlorine atoms. And this is a molecule of chlorine that we can see here. To test for that chlorine gas, I'd expect to observe bubbles. However, that could be bubbles of any gas. So to prove that it's chlorine, again, I'd use damp blue litmus paper, which would turn red, then white if chlorine is present. At the cathode, the sodium cations migrate to the cathode, again, because they are attracted to the negative charge. When they arrive, those sodium ions are reduced this time because they need to gain electrons to form sodium atoms. And my observation would be solid metal observed on the cathode. For higher tier students only, extra little bit, the half equations associated with this. At the anode, we would expect two Cl minus ions to form a molecule of chlorine, which contains two chlorine atoms, and we'd also get two electrons produced as well as part of the loss of electrons. Please note the minus symbol on the E is not essential, but I like to include it because it helps show where the charge has gone, okay? And finally, we need to look at the half equation for the reaction at the cathode, which is reduction, and reduction being the gain of electrons due to sodium ions having just the 1+ charge. Each sodium ion will need to gain one electron to cancel out that 1+ charge. Again, not essential to include the little minus though, to form a sodium atom. Exam question time. I'm going to do this one. So using the bug technique, I've been told solid lithium chloride cannot be electrolyzed, but molten lithium chloride can. I've got to explain these observations. It's worth 2 marks. So I've basically got to say what's going on and why. Great connective to use is because as part of an explain question. And for the solid, I know it cannot be electrolyzed because the ions are not free to move. But with the molten lithium chloride, it can be electrolyzed because the ions are free to move. Key parts to this are referencing what's carrying the charge, i.e. the ions, and the fact they're able to move. Next question. Which row of the table shows the products formed at the anode and the cathode when molten lithium chloride is electrolyzed? I've got to tick one box. Now, going on in my head at this point, I'd be thinking about the electrolyte. If it's molten lithium chloride, the only substance present is lithium chloride, and therefore the only ions present are lithium and chloride ions, okay? Metallic ions are always positively charged and non-metallic ions are always negatively charged. So, remembering, panic, positive anode, negative is cathode. The negatively charged ion will be attracted to the anode and the positively charged ion will be attracted to the cathode. In which case, chlorine and lithium as part of D is the only acceptable answer here, okay? A is similar, however, the ions are the wrong way around, okay? The positively charged lithium ion is not obviously going to be attracted to the positively charged electrode because they have the same charge. Remember, opposites attract. Right, we've got a redo question here. We've got a different scenario. This time we're being told that in an experiment, a student used solid ammonium chloride as their electrolyte, or they attempted to use it as their electrolyte, and the lamp as part of the circuit did not light up, but when they used ammonium chloride solution, the lamp did light up. They've been asked to explain the results of the investigation. Our student has written this in purple. Out of 3 marks, I'd like you to pause the video and have a think about how many marks that student would get. Right then, they've only demonstrated one bit of scientific understanding here, and that's related to electrical conductivity and whether the lamp lights up or not, okay? So they would only achieve 1 mark for this, okay? Saying that it does light up when electricity can flow or when there is electrical conductivity, and saying the lamp doesn't light up when there isn't electrical conductivity is the same bit of scientific knowledge and understanding. For the second and third mark, they had to reference ions and the flow of charge. Okay, we've got 2 questions for you to have a go at now. 2 marks, so try to spend no more than 2 minutes on this. Pause the video and I'll review in a moment. So for the first one, we should have C as our selection for that one, chlorine and zinc, chlorine at the anode and zinc at the cathode. And for our second question, it's D because it contains ions that can move. Next, slightly different scenario that I'm going to approach and demonstrate how to tackle this question with you. I've been asked to state how we would change the electrolyte to obtain metallic sodium based on the fact that sodium chloride solution does not produce metallic sodium. It's only worth 1 mark. Now, a solution, or an aqueous solution, contains hydrogen ions and hydroxide ions as well from the water, i.e. the solvent that was used to form the solution. Okay, so clearly solid sodium chloride must have been dissolved in water to form this solution. So, solutions do not always form the product based on the solute. Okay, so in this case, we're told that we're not getting sodium formed, sodium being the cations present, we're not getting sodium formed, we're probably getting hydrogen instead. So, how I would change the electrolyte? Well, if I wanted to guarantee the production of sodium, I would need to ensure that I only had sodium ions as my cation present in that solution. So I'd use molten sodium chloride instead. Right, a good selection of questions now to test your knowledge and understanding. This covers the broad spectrum of what I've reviewed with you so far. This is sort of grade 4 up to grade 5 standard. Pause the video and have a go at these, and I'll review in a moment. Try to spend no more than 10 minutes, which is approximately 1 minute per mark. Right then, first one, electrolysis. That's the name of the process. Next, 1 mark. I'm expected to demonstrate that I have knowledge and understanding of the presence of ions and their need to be able to move or flow for that one. The next one, key term here, it's a solution of sodium chloride. And if it's the ions attracted to the anode, we're looking for negatively charged anions. So both the chloride and the hydroxide need circling. Test for chlorine, 1 mark for mentioning blue litmus paper. Okay, damp isn't essential, it's in brackets, but always a good idea to include. And what we would observe is that it would turn red, then white. Bits in bold there are the essential details. 1 mark for the first line, 1 mark for the second. Chemical test for hydrogen, put a flame in the gas or ignite the gas. And second mark, you'll hear a pop or it explodes, okay? Squeaky isn't essential. And finally, what must be done to the electrolyte to obtain results? Melt or dissolve the solid, or melt or dissolve the copper sulfate. And our reasoning, because it's an explain question, because the ions can move or flow, okay? And therefore they'll be able to carry the charge. Right, final round of you do questions. First two applicable no matter what tier you are sitting, and the final one is for higher tier students only. So we could have the involvement of a half equation here possibly. Pause the video, have a go at these, and I'll review in a moment. Okie doke, first one. Molten potassium bromide is only going to produce potassium and bromine, so it was D. Identifying the gas, well, we're told that we got a squeaky pop when it was tested for, so it must be hydrogen. And for the third question, we get 1 mark for referencing hydrogen or H+ ions being attracted to the cathode, a second mark for reference to reduction or those ions being reduced, and a third mark for reference to the hydrogen ions forming a molecule of hydrogen when electrons are gained, or having the correct half equation showing reduction occurring, i.e. 2 hydrogen ions gaining 2 electrons. You can include the little e minus if you wish, and our H2 hydrogen molecule being formed. And that's mission complete. Electrolysis, key concepts all covered in that little session, with the most common exam questions being shown to you there with plenty of practice. If you found that useful, please hit the like button, and for more science mini masterclasses, please subscribe to my channel. See you in the next one.